Sure you have your 10-3 out so that we can do this together. And I would like to work with you on the worksheet. I'm going to do one from each section so that you can see not only which theorems we're using, but how we're writing them down and what it means, okay? Okay, the reason your paper is different from mine is the only difference, gentlemen and ladies, thank you. My paper is using a large font version so that it's easier to see when you project. Otherwise, I have to do a lot of moving the paper around for us to read all the directions. Yeah, that's the only difference. It's just mine is size. Mine's bigger. Okay, so they want us to find the value of x. If I can have your attention, please. Thank you. We're looking for the value of x in each of these circles. We need to round it to the nearest tenth if we have to. If we don't, then don't worry about it. And we need to make an assumption. That means that we're going to go ahead and just, no, don't prove it. Just go with it, okay? Anything that appears to be a line tangent to the circle is a line tangent to the circle. All right? Let's look at number 1. Let me zoom in a little more on number 1. Which setup does number 1 appear to be? Look back through your notes and through your diagrams. Read for me that one.
If two chords in the
okay. Thank you. Let me interrupt you. If you'll read the title of that one.
Yeah. Theorem 1.
Secant Theorem 1.
Yeah.
All right. So for this one, we are going to be using Secant Theorem number 1. That's the one that reads. All right. If everyone will look at the theorem, it should read something along the lines of this. If two chords intersect inside a circle, then the product of the measures of the parts of the chords are equal are equal to each other, right? Are equal. Yeah? All right, here's what it means. And I'm going to use some colors to help me demonstrate. I need to name, look, my intersection doesn't have a name. Can someone give me a name for my intersection?
D.
I heard D?
Yes.
All right, we'll use D for this one. You can name your intersection point anything you like, but we're going to go ahead and use D. All right, so here's one chord from K to M. Yes?
Yes.
All right, here's one part of it from K to D. So KD times the other part DM. That value is going to be equal to, we're going to look at the other chord now. Shh. Hey, stop the side conversation, please. Thank you. L to N. But we want to look at the parts. So we're going to look at the part L to D. And we're going to multiply that to this part over here, D to N. All right, makes sense what we did so far?
Yes.
All right, let's substitute what we know. What is the value of KD? 3. All right, I'm going to use parentheses to write my multiplications. What's the value of DM? X. All right, that is equal to, what is the value of LD? 6. And the value of DN?
7.
Beautiful. All right, let's continue solving for x. How do I write 3 times x?
3x.
I write it as 3x. What is 6 times 7? 42. All right, how do I get rid of that 3? Divide by 3. X is going to be some number, yes? All right, I don't know what the number is. You go to your calculator, you figure that out, and you write it in. Where do we get what from? This right here? It's secant theorem number 1 from your notes that you just took.
14.
Yes, I'm a wizard.
You are a wizard.
It's 14.
All right, this is directly from the notes you just finished taking.
It's 14.
All right, look at number 2. It's exactly the same setup as number 1. It's the same setup, yes?
Yes.
All right, you can do number 2. Look at number 3. Is it the same setup as number 1?
Yes.
Yes, you can do number 3. Turn the page and let's do number 4 together. Which setup though? 2. Theorem number 2. So this is secant theorem number 2. All right, secant theorem number 2 says for us to take the parts of the secants, multiply them together, and then they're going to be equal to each other. So this secant right here from C to L has 2 parts. It has that part C to D, and it has this part D to L. So we're going to take CD, we're going to multiply it to DL, and that is equal to the parts of the other secants multiplied together. So here's the other sequence, L to N. So NM is one part, and we're going to multiply it to ML, the other part. All right, again, I'm going to use parentheses to separate my multiplications. So let's substitute. What is the value of CD?
4.
4. What is the value of DL? X equals the value of NM
7.
and the value of ML?
5.
Lovely. All right, 4 times X is written as?
4x.
And 7 times 5 is?
35.
All right, and how do we get rid of that times 4?
I got the answer, but I'm not telling you.
All right, don't tell anyone.
Must be a wizard.
Hey guys, this walkthrough's for you. I'd appreciate no side conversation, okay? We're almost done. All right?
Yes.
Okay. Take a look at number 5. Is it the same setup as number 4?
Yes.
Yes. So can you do number 5?
Yes.
Beautiful. Look at number 6. Is it the same setup?
Yes.
Beautiful. Can you do number 6?
Yeah.
Lovely. All right, let's look at number 7. Actually, I'd like to look at number 8. It's more complicated. All right. I want you to ignore number 9 unless you feel like a challenge.
I don't want to challenge.
Okay? Because with number 9, you can do the setup, which is what you'll be graded for, but I don't want an answer.
Do we have to do number 8?
Okay, so for number 8, for number 9, you're gonna show me the setup only. All right? I expect you to be able to do the setup on number 9. Okay? You don't have to solve for the answer all the way down to X, but you will do the setup.
Can we?
All right, here's number 8's walkthrough.
Oh, we're doing
Which setup is number 8?
that one. Oh.
What's the setup?
Tangent.
The tangent secant theorem. Yeah, number 8. Tangent secant theorem. That theorem says when you have a setup like this, the square of the tangent equals the product of the pieces of the secant. Which one is the tangent?
R.
L to R or L to G?
L to R
What's the definition of tangent?
is the outside.
It touches the circle in how many places?
To 1.
In 1.
Yes.
The secant is the line segment that touches in 2. So which one is the tangent?
The LG.
The LG is the tangent line. And so LG, we're going to square it. And then we're going to take the parts of the secant, this part and this part, and we're going to multiply them together. All right, let's substitute what we know. LG is, okay, LH is, and HR is X plus 6. All right, now this is looking a little more complicated, right? Just a little bit. Let's walk you through. Make sure you can do this. What is 6 squared? 36, because it's just 6 times 6. Very nice. How do we handle the 2 times the group x plus 6?
Distribute it.
So I'm being told you guys are doing a lot with your hands. You're doing these little hopping things. And someone had said distribute it. So 2 times x is written as,
2x.
and 2 times 6 is,
12.
can you solve it from here?
Yes.
All right. So then you will continue solving and find an answer for x. Yes, decimals are allowed. Please remember that you must round to the nearest tenth. That's 1 decimal place if you need to. Thank you very much.